Hello, everyone. Welcome to the ASME FutureME Career webinar. My name is Michael Serda, and I'm part of the Volunteer Digital Engagement Team, which is part of the ASME Early Career Engineer Programming Committee. Today, we have three experts joining us to share their journey and discuss their career paths. Stay tuned until the end as we will be announcing a fantastic video submission project. This project offers participants the possibility of being featured on our Facebook and other social media pages. Now, we're excited to hear from our three incredible guest speakers. First, we have Columbia Mishra. She's a senior thermal engineer at Intel Corporation. Prior to this, she worked for industries such as Apple in California and Mackinac Asia in Singapore. Columbia is a mechanical engineer by training, receiving her PhD from the University of Texas at Austin, master's from Texas Tech University, and bachelor's from Jadavpur University. During her PhD at UT Austin, she was elected as the president of the engineering student body and the president of the university student body. She has received the Cockrell School of Engineering Student Leadership Award for her contributions as the graduate student body president, representing 13,000 students to the university administration, City of Austin, and Texas legislature. She was a recipient of the competitive Qualcomm Innovation Challenge Fellowship for her research, a passionate space enthusiast. Columbia is en route to becoming a trained pilot. She mentors first-generation high school students in Portland, and she holds the title of Miss India Oregon 2019 and uses the platform to raise awareness about social issues. Right now, she lives in Portland, Oregon. Columbia, we're glad to have you here. Thanks for being with us. Next, we have Ram Gupta. He has completed his Bachelor's of Engineering in Mechanical Engineering from BITM VT University, Belgaum in the year 2012. He started his tenure from L&T Technology Services, Baroda, in the same year as design engineer. Then he was relocated to Alabama in the year of 2016 by L&T for the organization's on-site support requirements at Polaris Industries. He is currently working as product design engineer in Huntsville, Alabama. Mr. Ram Gupta has a great experience in tooling design, time study, human simulation, assembly simulation, and his knowledge has helped industries to increase their manufacturing efficiency and reduce costs. Ram, we're very excited to hear your story. Thanks for joining us today. And our third speaker is William Gibbs IV. He graduated with a degree in mechanical engineering from Seattle University in 2008. He started as a test engineer in D&V Global Energy Concepts, and then worked as a mechanical and controls engineer for Electro Impact. In 2010, he started a company called Corvus in Columbia, a small firm that designed, built, and supported custom tools, machines, automated equipment, and applied robotic systems for startup to mid-sized companies. After that, he became the engineering program director for Cascadia Automation Solutions. In 2015, a product development consultant for Storm Sensor. In 2016, now he is the founder and CEO of MODICA Microindustries, Inc., a company that builds robotic and human workspaces inside shipping containers and architectural prefab structures created to create manufacturing capacity anywhere on Earth and eventually in space. William, we're grateful to have you with us today, and we look forward to hearing more of your story. Now, I'm so excited to learn so much from this discussion, and I hope everybody has the same attitude. And so let's start this webinar with William. William, I know that you took a lot of roles on the way to becoming the CEO and founder of your own company today. Was taking a lot of roles part of your plan? And I think the bigger question is, what was your career plan right after you graduated from college?
That's a great question, Michael, and just want to say thanks for having me on. This is a great program, and I'm really happy to participate here. The course I took really wasn't my plan, but the fact is that I didn't really have a strong plan. I did know as I was going through undergrad that I was interested in product design, I was interested in robotics, I was interested in renewable energy and some other rough areas. But I didn't have a strong strategy or really a game plan in place to get into any of one of those specifically. So right as I graduated, I really was just looking for a job, to be honest, but I did know that I had those sectors that I was looking for. And this is something that I actually advise to current engineering students, which is you don't have to have a plan really. You don't have to know exactly what you want to or like to do, but it can really help to at least narrow it down to a few sectors, even if they're very broad sectors. Of course, mechanical engineering is an extremely broad field, and it does help if you can find at least a few directions that you might want to head. But it's totally not necessary. You'll kind of find your way. I would say that spending a lot of time with yourself and thinking about these sectors and what rough directions you might want to go can be time very well spent. And then also bouncing that off of others. So if you have mentors or friends, even family, just they'll help inform as well. Maybe based on your personality and what you're interested in, can help you at least go off in one direction. You can always change that direction too. So.
Totally agree. But from what you said, it's very encouraging to know that you don't need a solid plan at first. And I think a lot of students right now, or even early career engineers, are struggling because they don't have a solid plan and they think that, oh, I don't have a plan, I won't be successful. But with the amount of accomplishments that you have right now, and knowing that you didn't have a solid plan at first, that's very encouraging for early career engineers. But let's talk about your company, MODICA. How did you start it, or how did you come up with the business idea?
Sure, that's a good question. Again, I'd like to say that it was a instant kind of flash of inspiration, and I immediately had this amazing plan in place. But again, there were inklings of plans and kind of rough directionality. But really, MODICA is kind of two parts. There's literally two groups within the company. There's the manufacturing technologies group and the properties, structures, and logistics group. And they each kind of do a different thing. But the story of how MODICA came to be involves both of those. One is my first business, Corvus and Columbia, was a systems integration firm, which really means a bunch of engineers spend time matching clients' manufacturing needs with commercial off-the-shelf and other existing industrial automation technologies like robots and their end effectors and conveyor systems and process tools. You're just kind of mixing and matching the pieces and putting them together. I realized that even though that was my business, that was a lot of wasted effort. It was actually it was reinventing the wheel or reinventing the robot, so to speak, over and over again. And I thought that was kind of wasteful, even as I was doing it. And then the second piece, the property structures and logistics part, was really from the pain I had as someone running a small business, Corvus and Columbia, finding a commercial space and an industrial space to lease and use to run the business. Commercial leases are long-term, they're really expensive, and there's always this kind of pain point of building out within a place that you're leasing to build your office space, to build your shop. So MODICA combines both those. We make the systems integration more automated, kind of automate automation in a way, and we put them in a physical form factor that is a lot more flexible for where the factory is actually built or where your office is built. So that's the prefab and the shipping containers. They can be put anywhere, and it's a little bit easier than dealing with commercial leases. So that's where it all came from. It took a lot of fine tuning, and I think it wasn't a flash of inspiration. It was a lot of hard work and dead ends and pivots and finding where we are now.
It's safe to say that it's like the fruit of all your labor for so many years that you've been working, and also you also like used your first business as inspiration for this company.
Yeah, that's true.
Yeah, but I think one more important question about MODICA, or even starting up a business in general, is were you working full-time as an employee and then working on your company at night, or was it like a full transition to working full time at your own startup?
Yeah, that's a good question. There was a bit of a transition. So before I started Corvus and Columbia, I was working at Electroimpact. I was doing aerospace automation work, and I started thinking about and helping other people with mechanical design sort of on the nights and weekends, unrelated to aerospace. And I just started getting a little more interested in that, and I started getting more questions from people about projects I could help with. And then the big cutoff, and probably the main reason I formed that company and went that avenue, is I had some health issues in the family, we'll say, and I had to travel back to Idaho for some time. And during that time, I realized I needed to be flexible. I needed to, I couldn't be at that job at the time. And I really just ramped up the side work I'd been doing, and kind of crash course in starting and running an early business. At that time, it was just myself, but that crash course in starting and running a business continues to this day. It's an ongoing thing.
Okay, yeah, that's good to hear. But my greatest takeaway from your story is that resilience and just trying out things, it pays off, because you'll never know. And also, it like when you have a career where you tried out a lot of things, none of those experiences are wasted, and you can always go back and use those skills that you have learned all throughout those years, and then come up with something that you love, right? And when speaking of doing something that you love, and a lot of engineers today I know are planning to start up their own companies. If you're gonna give out just one advice, what would it be? What advice would you give to engineers who plan on starting their own business?
Sure. Yeah, it's hard to narrow it down to just one, but this question makes me think about a quote I really like, which is, I think, Louis Pasteur, that opportunity favors the prepared. And I think that's totally true, but the caveat is that you never will be truly fully prepared. So choosing to start a business, or even becoming involved in a startup, it needs to be a combination of things. You know, if you really feel that that's just your destiny, that can be one piece, but it needs to make sense in the context of what your aims are professionally. I think there are a lot of avenues to getting into business yourself, and I think the best thing to do is to be prepared and kind of be smart about it, and also always seek input from others. That, I guess, if I had to narrow it down, it's like really build your network and rely on your network. That applies across the board, whether you are thinking about doing a startup or your own company, or you have no intention of it. Really building a network of your colleagues, of friends, keep your family close. That network can help you in whatever professional pathway you want to take.
I totally agree. That is very good advice. Yeah, building your network, something that we should all do as engineers. Well, thank you so much, William. Now we're going to move on to Mr. Ram Gupta. Hi, Ram. You are now a very successful design engineer and have helped many industries in India and US to reduce manufacturing costs. This is really an amazing accomplishment. We noticed that you did your undergraduate studies from Belgaum, India, and we are super interested to know about your journey from an undergrad student as an undergrad student in small city of India to working as a design engineer at Alabama.
Thanks for inviting me here. It's an honor to be here, and thanks for the question. So I graduated from Bellary Engineering College back in 2012 from a town called Bellary, which is in state of Karnataka in India. And I guess my college wasn't among the top ranked college or a very popular college at that point of time. Now it has gone through unprecedented growth, and now it's a very good college, but back then it was kind of an average college. So I guess the biggest challenge for me was we did not have so many mechanical companies coming to our college for campus recruitment. And we had some of the software companies, but I wanted to get a job. I wanted to earn money. So I decided to give a shot to the software companies, even being a mechanical engineer. And I got selected in one of the software companies, and almost I was about to join that company. But luckily, few weeks later, I got to know that L&T Technology Services is coming for a off-campus drive and kind of doing recruitment for all the colleges around. And I went there. It was a big competition. I got selected, and then I did my training in Mysuru for 3 months and then moved to Vadodara, India. I was involved with various projects related to time study and value engineering, design simulation, and human simulation. And it was 2015 I got nominated for US visa, since I was working with all the basically US companies, US based manufacturers. So I got nominated for US visa and I got my H1B on 2016. And 2016 April, I got my first assignment in San Diego. So took my long flight of almost 45 hours and landed in San Diego. And there I was supporting for a new manufacturing line setup activities. So I was there for almost, I guess, 4 or 5 months, completed my project, and I then got recommended for a new project in Polaris, Huntsville, Alabama. And that was also related to new manufacturing line setup activities. So here also I completed my line setup activities for almost 3 or 4 months, and then uh, they wanted to retain me. So they asked me if I can support with new product development and basically design stuff. So I didn't have any prior experience with design, but they told they're gonna teach me, and it's been almost 4 years that I'm working with product design engineering,
Oh,
and that's how I am here.
wow. I think that's really cool. You have a very interesting path, and from where you started in India to where you are right now, and that I think that really inspires a lot of people, not only in India but people from emerging countries. And I
Yep.
think one good question to follow up that response is we should consider that every year more than 1.5 million students become engineering graduates in India. And no doubt it is because of these engineering graduates that India is one of the fastest growing nations. But the fact that more than 1.5 million engineering students become graduates each year, there's an intense competition between engineering graduates. If you would give some recommendations or tips or advice, what are those recommendations that you would give to engineers in emerging countries to make them competitive and achieve a similar success that you had in your career?
Yeah, I like the word emerging. And yeah, like you said, 1.5 million people, 1.5 million engineering students graduate from India every year. And obviously, there are not that many jobs for engineering graduates in India. So the market is flooded with engineers, and it's a big competition. So I think there are few things that an early career engineer should prepare themselves for. The first thing that, based on my experience, the first thing that I can think of is uh, we should be hands-on as much as possible, even during our academics. I mean, a lot of companies that come for hiring, they look into you if you are, I mean, if you have practical knowledge or if you are hands-on. So you really need to be hands-on as much as possible. I mean, apart from academics, there is internet. There are so many other means you can start looking and keep yourself, make yourself hands-on. The other thing I would say, companies also look for how well you are a team player. So you can start taking part in extracurricular activities in your college, either it is games or college magazine or social activity, whatever. Just try to work with other people and try to get around and build up your team player quality in you. And the third thing I would say is the technology is changing every day, right? So I mean, whatever we think of or plan for today may not be tomorrow. And market conditions are also changing. And a lot of unpredictable things are happening like this pandemic. So you need to be very, very flexible and open-minded and ready for anything. Like if I heard it well, William was mentioning that you can plan and narrow down things, but you cannot plan everything absolutely, right? So you can narrow down and plan it, but you need to be ready for surprises and ready to face that. And hey, why not exploring self-employment? I mean, if I don't get hired, then you should also explore for self-employment. Indian government is encouraging small scale industries, small business these days, and also giving subsidy. So, and I think other emerging countries might also be doing that. So you can also explore the opportunity for self-employment. And last, I would like to say, based on my experience, like if I look back, my batchmates, some of us were really good and some of us were not, we could not make through the campus selection. But if I look back and see everyone who kept trying, they are all in a good position right now. So I would say if you didn't get through a campus in college, it's not end of the world. Keep trying and be patient, and you absolutely gonna get it.
Thank you. Those
Yeah.
are great points. I really appreciate you that you mentioned being flexible and looking at other options. Because if you were not selected during your first try, why not? Why stop, right? And why give up when you have a lot of options? Um, Follow up to that question is: have you ever been in a position, or do you think it's okay? Because given that the job market today is very extremely competitive, right? And a lot of people are really, really struggling to find jobs. If you are an engineer, do you think it's okay if you try out other fields or other professions that are not in line with your passion?
I I think, yeah, it's up to you. I mean, there is nothing bad in trying other options. As I was mentioning, the competition is very, very high, and there is a big competition here. So everyone's not gonna get job in fields they like, right? The world is not working according to us. So it is all right to be in other fields for a while, and at the same time, keep looking for opportunities we like.
Okay,
Yeah, but
thank
I
you.
think it's absolutely all right to, and like for example, if I look back in myself, when it didn't seem like so many mechanical companies is gonna come to my college. I appeared for software companies. So my plan was I'm gonna work for software companies for a while to have something in my hand, and then I will keep looking for mechanical companies or the fields I like. So I guess it's all right to be uh, uh, other than the fields of your passion, and eventually you're gonna get it. That's what I feel.
All right. Thanks for
Yeah.
sharing your ideas and position regarding that. Yeah, because the reason I brought that up because a lot of engineers today are facing that dilemma. You know, if I keep on following my passion, whatever a role that is, whether you're a mechanical engineer, electrical engineer, or a civil engineer, but the jobs are just not available right now. Should I take on another job that is not really in line with my goal or my career path that I'm thinking about? And so, yeah, absolutely is worth it to take a shot at other options. Thank you, Ram. Now we're moving forward. We're going to start our discussion with Columbia. Hello, Columbia. Uh,
Hey.
I was expecting that a person who has a PhD and was a university student council president, Miss India Oregon, ASME Eclipse intern. Oh, I wanted to be an intern. Technical program chair of ASME Summer Heat Transfer Conference and has experience of working in Qualcomm, Apple, Intel, and flying an aircraft. That person's age must be like 60 years because of all the accomplishments And honestly speaking, I don't know if I'm going to reach that level, but you have accomplished so much in your early career, which is absolutely amazing. And that is why we're very excited to know more about your story. So let's start by telling me about your journey from being a graduate student to achieving all your great accomplishments, especially as a senior thermal engineer at one of the biggest companies in the world, Intel.
First of all, Michael, thank you so much for having me here. And it's such an honor to be serving on this panel with William and Ram, such accomplished engineers and achievers themselves, and yourself as well. And I'm really glad to be here. And secondly, age is just a number. What we bring, so what we bring to the table is not a function of our age. And I encourage every early career engineer to not be encumbered by what their age is or what their experiences has been. Just think of what you want to do and what you have to offer. It's not a function of time. It's a function of value. So just remember that. Going back to my undergraduate days and how I am here at Intel at this point, I graduated from Mechanical Engineering Department at Jadavpur University, Kolkata in 2006. And I was a part of the centennial batch of students. So it was 100 years for the department in mechanical engineering. Unfortunately, I have to point out I was one of the 2 girls in the class and one of the 3 girls in the entire department. 100 years after the department. So that's something I'm still struggling to wrap my head around even till date. But at the same time, I finished my undergrads. I wanted to come to the US and experience a different culture, get my master's education, and I was very interested in thermal fluid systems, and I did my master's thesis in highly viscous fluid flow and did theoretical work. And at the end of it, that experience, I was definitely very keen on doing a PhD. And sometimes things don't go according to the plan. And what happened in my case is I ended up choosing a position at a company in Singapore for a bit. And I went over to Singapore, traveled a bunch, got some hands-on experience, very different from my theoretical fluid mechanics research, and ended up coming back to accept a job offer in Houston, Texas in oil and gas with Stress Engineering Services. And this was in 2008, right at the beginning of recession. And I had a job offer. It was extraordinary to work with a bunch of PhDs. Stress was an engineering consulting company with over 300 PhD engineers, and I was one of the 2 or 3 people with a master's degree, and it was very awe-inspiring for me, and great place to learn and great work culture. And somehow I wasn't very pleased with my path, because I was like, I want to do a PhD, and I am at an oil and gas company, which is great, but I have a job, I'm lucky. And I even got my H-1B, the work visa thing, which is so hard for immigrants to get. And very bravely, I decided to leave it all behind, go for a PhD. So I announced on 21st July 2009, the date is important because that's a late date, man landed on moon, 20th July. I announced it to my parents, I am leaving my nice paying job with a visa to go back to school to be a poor graduate student. And I went back to PhD. This time around at UT Austin, I wanted to do more hands-on, like more practical side of things. So I chose to do experimental research, and I was working on graphite, ultra-thin graphite heat exchangers and graphene and so on, with applications for thermal management in microelectronics and in consumer electronics. Eventually, I realized that I'm more interested in the nanoscale thermal transport aspect of it. So the inherent internal theoretician in me took over, and I ended up switching my results, like my research, into working on nanoscale thermal transport. So I ended up switching from experiment to computational fluid dynamics research. And during that time frame, I had the opportunity to intern with Apple. working on their printed circuit board designs for consumer electronics, for MacBooks and stuff like that, with the thermals aspect in mind. And that experience was very crucial to me, realizing that there is a path for mechanical engineers in the tech industry, and there is a very meaningful way for us to contribute in that. Like, because people, when they think of tech industry, they think that, oh, it is all about like software engineers, and what is a mechanical engineer going to do there? And there's a lot you can do at a company like Apple, Intel, and so on. So from that experience, I was working on FinFET MOSFET, which are part of the microelectronics, and I was looking at the thermal transport there. I won the Qualcomm Innovation Fellowship, so 2 years of my PhD work got supported by Qualcomm, which was a great thing that happened for me. And through that process, I figured out that there are like very high possibilities of having a career path doing something very similar to my research area at a place like Qualcomm or Intel. And I don't just have to do like macroscopic or like continuum scale physics, but instead I could be doing like nanoscale thermal transport, even in the industry. So that was great. When I was about to graduate from my PhD, you can imagine, as an immigrant or an F1 student, it was very difficult to look for jobs, like find a job that will sponsor my visa and all that stuff. And it was really great timing that Intel came for an on-campus selection, and I went to those, those information sessions, and I attended a talk on resolution enhancement technology or optical proximity correction stuff, which is related to photolithography, and which was not at all my area, but the only commonality was the computational aspect and writing codes to solve for mask corrections in computational photolithography. So really, I ended up taking that job at Intel, and I joined Intel in that role as an R&D design engineer. I spent a year doing that, learned all about like, OPC and computational photolithography. And then I was like, my true calling is really thermals. And when you are in a company like Intel, it's very easy to see the other parts of the company, and there are other areas people are working on, and connect with them. And like, one thing that helped me is my networking, and people I have connected during my graduate school and through the conferences and stuff. They reached out to me actually and said that, hey, we have an opening in the thermals area. Are you interested? And I was like, oh, I'm doing this really cool thing. This is very unique, new stuff that only company like Intel does. And they're like, yeah, but you will be very helpful to our team. So I ended up moving into this other team. And now I have been with the same team for the last 3.5 years, and I've been working on as a senior thermal engineer there. I do a lot of technology development, pathfinding work. I get to do a lot of roadmap execution, real Intel products. And yeah, it's a lot of CFD. There's a lot of hands-on stuff that you need to do, like get in the lab, do experiments and so on. But really, that has been my journey into Intel. A little windy, but I'm there now.
Wow, that is such an inspiring story. What I can say is I'm really thinking about doing a PhD right now, and just hearing from your story. And I'm about to finish my master's degree, and there's a lot of things going in my head. Should I do a PhD? Should I work? And I won't be able to earn that much as a graduate student again, and that's going to be for 4 years. So those are sharing your story gives me a lot of insights, and not only to me, but to all watching this webinar. I think that they can pick up a lot of lessons from what you've told us. One thing that that discourages me from doing PhD is, it's all the jokes that they tell. PhD stands for permanent head damage, But actually, that if that's the option for you, I would connect it back to RAM. Like, if that's the option for you, then why not take it, right? So it really depends on what you want to do. I'm just sharing what I've learned from you. It really depends on what you want to do and what are your options right now.
Right.
But one thing that I also liked about what you said is the number of women in engineering courses. I think I can relate to your experience. I think in my batch, we only had 3 women who did mechanical engineering. But I guess the numbers are increasing, so that's a good thing. Do you think that even in today's time, when people say engineer, they usually think that it's more of a man's job rather than a woman. What do you think is the current situation is right now for women in engineering, and what can you say to women who want to pursue a career in engineering, and how will you encourage them to go for their dreams of becoming an engineer?
I would say do it. See, the point of pursuing any career is how it aligns with your personal values, what you are passionate about, and even if the road is long and windy, you will get there. And my point is, if you are a girl or a boy or whoever you are, and you want to study engineering and you are excited about physics, you are excited about maths, and you're excited about figuring out how things work, engineering is totally an option for you. And irrespective of where we stand as a society and how we stand as institutions and organizations at the moment, I think the key is to have more diversity in any of these places, and that's the only way it will become more inclusive. The current state of affairs, I would say, is we do not have as many women and minorities in workplace like we would like to have in engineering especially. But that said, I don't think but I think that organizations are really striving towards it. I know that Intel has their diversity goals. When I was at UT Austin, my department had diversity goals, and they're working towards it. The important thing is we are aware and we are trying to make it more inclusive. One thing I do find is something that we all need to work on is we all have our blind spots, and we ourselves can be allies to make sure that women and minorities are included as part of each and every important decision regarding design or manufacturing or any engineering decision, because diversity in thoughts will also help have a better product in the end. So just be aware of the micro inequities that happen at a workplace. And it can happen not just because of your race or gender, it can also happen because of your personality. Some people are just they may not feel comfortable speaking up, but when the leaders in the room, I think it is their responsibility to make sure that person is heard, their viewpoints come across, because anybody who is in the profession has some ideas. And now once you're in the workplace, once you're in that company, you definitely have good points, right? And to articulate those, I think the leaders need to encourage and make sure everybody is included. And one of the things I think there are a lot of students watching this, I have some advice for them, like that they could be doing as allies. Like, hey, if you have girls in your class, be inclusive of them as students. An example of what you could be doing is make sure that the study groups that you have includes these students who are girls in your class. Don't have a study hour at a very odd time, at a very odd location where some of your female colleagues may not be able to participate in. Try to be inclusive by choosing a place and time that will allow for that to happen. And I can say that because I experienced that in the beginning of my engineering college education. But then later on, some of my friends noticed that I was not able to participate in those study groups, and they actually made sure that I'm included, and they picked time and place where I was able to participate. So I think those are some little things each of us can do. Even the students, current students can do, managers, employers, even like colleagues, they all can do. Just be respectful of everybody and try to include them.
Thanks for sharing that. Well, actually, your career story is a prime example of how far women can go as an engineer. And so thank you for sharing your story with us today. Well, I think the last question for you for this discussion is, let me go back to what we talked about earlier, or what you've talked about earlier about grad school. Due to COVID-19 and all the effects of the pandemic, people are starting, or students specifically, or early career engineers are starting to rethink, maybe this is a good time for me to go back to grad school. And for someone who's thinking that way, what advice would you give to those people who are planning to go back to school, and what are the challenges or what are the struggles that they might encounter, and how will you respond to those struggles? Because you've been there. You have been a master's student and a PhD, so I think you can give pretty good advice to all those people.
Yes, definitely. It can be easy to go through school right after bachelor's, master's, PhD. It is easy that way when you don't have to go into and out of different industry academia, because it's all in the flow. But when you are trying to do things with a break, like you go back to work and then you work for a few years and now you want a different education, it can be challenging because it takes preparation to apply, etc. And also once you are there, things will be different. You get used to the work culture, and like the life is different when you are working, but as a student, life is different. And you have to like turn in homeworks and, you know, round the clock, there is no weekend and things like that. So those things are to keep in mind. But what I think anybody who is considering going back to school or going to school, I just want you to answer these questions for yourself. Number one, what is it that you want to do? Or what is it that you want to get out of that education? And number two, are you doing it, like the degree that you're picking is really going to take you there? So these are very simple questions, because I think it is easier to think that, oh, the economy is down, I will just go back to school. But if it doesn't serve a purpose, then, you know, it's kind of moot. I switched during the recession. Like I got my job around the time the recession was starting, and when I left my job and I went for PhD, it was recession time, and there was a lot of pressure from you know, family and otherwise, like, why are you leaving a good paying job to do this now? You got a visa sorted out. So you have to be able to stand up to all those pressures also when you decide to go back to school. So it's important to know why you're doing these things. And going from academia to industry, I think it can, if you want to know, if you know you want to go to industry and you don't care so much about research anyways, I would recommend not doing a PhD, because because PhD is only when you really want to devote several years of your life to further the research in a particular domain. And you're willing to sacrifice your personal life. You're willing to sacrifice all your weekends for all those years to do it. So don't do a PhD because, okay, it's just it seems like a time to do it because nothing else is working. Don't do it that way, because you will be suffering. It's not easy, and only, I think 37% of the people who enroll in PhD end up actually graduating with the degree. I think this is inclusive of the other disciplines as well, not just engineering. And this is based on a data from back in 2013 or something. But yeah, the point is very few percentage of PhD students actually end up graduating with the degree. So you don't want to waste your time if you are not sure. And also be very, very picky about who you do the PhD with, because the single most important factor in your success as a PhD student will be your advisor. So just be very careful who you are committing all those years of your life. So I don't want to sound like very alarming, but PhD is not a decision you take lightly.
Lightly, yeah. Well, thank you very much for your honest opinion. I think I needed to hear that, and also people who are planning to do a PhD needed to hear that. But again, the good thing
but
about
it is very rewarding. I don't want you to walk away with the idea that, oh, it's like, I would not change a thing about that decision. I love my PhD program. There were like lots of ups and downs, and I felt terrible at times, but I wouldn't change a thing about it. I had experiences that resulted me in, you know, realizing certain policies within the university needs to change. And I actually ended up, that's the reason why I got involved as a student leader. And I wanted to change those policies and improve them. And that was the reason. And it helped me discover a lot of things about myself. And it was a very rewarding experience. So I would really encourage those who are clear that they want to work on something specific to actually take it on. So I don't want to be all like alarming, don't do it. It's more like be sure that you want to do it. It can be very rewarding for you.
Thanks once again. Thank you for that advice. The good thing about this webinar, I'm beginning to realize now, is you have to follow what you love to do, your passion. Well, if PhD makes you, if PhD would make you lose your mind, maybe that's not the best option for you. The good thing about this is hearing from all of you is like, if PhD is not really what I wanted to do, well, I can follow William's path. I can start my own company. Or if that's not the option for me right now, I can just stay in my job and immerse myself in the industry, just what RAM did, or like what RAM is doing. Or again, if I wanted to do research, then maybe even after Columbia saying that to me, my mind is really made up, and I'm ready for PhD. After I do my master's, and if that is your passion, that is my biggest takeaway from this webinar today. And I hope that everyone watching are taking a lot of notes from all our panelists, because this is actually what we're going to encounter and experience as we progress in our career. But before we end with this webinar and proceed to the Q&A, I think we have one more question for Columbia, and that is, what role did ASME volunteering play in your career?
ASME volunteering played a huge role in my professional development, especially after I was like a senior graduate student. When I was towards the end of my PhD, I was publishing and I was going to conferences such as the Heat Transfer Conference or IMECI, and I got involved with the technical committees there, and I got connected with the researchers and experts in the domain. And that was very helpful in my professional development. And even when I started working at Intel, I told you there were folks who reached out to me, and they kind of knew me because of my involvements through the different technical conferences, as well as what I was presenting at these different ASME conferences. So that was very helpful for me. And finally, when I got the early career leadership program internship, the Eclipse internship, that was actually super exciting for me. I got connected with people from different industries and not just my own technical domain. So that has been very exciting and a great opportunity for me. I have always been very interested in the space industry, and I want to know what's happening there, what are the technical challenges, and what the industry is pushing to strive for. And that actually the Eclipse internship have opened up an avenue for me to have those technical collaborations or discussions with people from those industries as well. So I think, and all in all, it's been a fun part of my life at this point, getting to participate in this webinar, for example, getting to share my experiences. This is a great example of, things that I find rewarding. So yeah, ASME has been pretty awesome. I think you should get involved if you're considering. If you're on the fence about it, like do it. Like you get connected with awesome people. I got to meet you today, Michael and William and Ram, and I would have no idea who you guys are unless I, got on this call and I'm on this webinar and all that. So
thank you for sharing. I believe there's a lot more opportunities in ASME, and so I think our role is, or everyone who's listening right now, I think the best thing that you can do is just to explore what kind of opportunities that you have with ASME. And just like this webinar, this is just one way for the ASME to help you out in your early career. And I believe that there are a lot more tools, a lot more opportunities that ASME can give you in terms of helping you out in your early career. And so before we go to the Q&A, I'd like to thank our three panelists today. Thank you so much for your time. Really appreciate it. To me, to wrap the session up, I'd like just to say that there is no single way, or you cannot limit yourself in terms of your career. Oh, I'm just going to do this, and then I'm going to do this afterwards. Because as William said, some of the plans that you made, they're not going to they're not going to materialize the way you originally thought that they would turn out to be. And sometimes there are a lot of challenges in life that you need to deal with. And I think the most important thing is to use all the experiences that you have gained, whatever job that you had in the past or whatever role that you had in the past. You can continuously learn from all those stuff and come up with something that you love, and then eventually do the thing that you love to do. And I think we have a lot of amazing questions for our panelists. Let me start with Columbia. So first question for Columbia. Aside from all your accomplishments as an engineer, you also had a lot of extracurriculars. How important were the extracurricular activities in your early career development?
Thank you for that question, Michael. In my early career, the extracurricular activities have played a very important role in the sense that it gave me a lot of confidence. It brought in joy, and which also energized me to continue working on my technical work and other areas. An example is like I am getting my flight license, like my pilot license, and it brings me a lot of joy, and it's a technical activity. It gives me the confidence and the energy and the enthusiasm to continue on my other side of life, which is my work as an engineer. And simultaneously, my extracurricular involvement with ASME and with the mentoring programs brings me a great deal of satisfaction and a sense of feeling rewarded in some way for me. And I think that's very important, to have a very well-rounded life. And I'm not very one-dimensional anymore. And it also gives me ideas in my work. Like I work on technology development, and I have to come up with innovation and new ways to solve a problem. And having these different experiences actually help me and give me a better, approach.
All right, thank you. The second question that we have, I think this is also very interesting. How important is a PhD for an early career engineer to be a good performer, especially in being part of an industry leading company such as Intel? Or in other words, does PhD give you an edge in terms of being a good performer in Intel?
That is a very good question, and there is a lot of debate around it. The main thing that I would say is, if you are sure that you want to work in the industry, you don't necessarily need a PhD to get a job in companies such as Intel, Apple, Google, anywhere. The advantage that a PhD gives you is a way of thinking. PhD is a training in your thought process and the willingness to dive into a topic and really solve very, very, very difficult problems that no one has solved before. So a PhD is useful in the long run for a company. So when you initially join a company, they may want you to deliver on certain deliverables that the team specifically has need for. And for that, you frankly don't need a PhD always. But when something is very complex, then you might need someone with a PhD or that level of thinking. As an example, the first team I started out at Intel, it worked on resolution enhancement technology, and this is something that is not taught in pretty much any school. Probably like 1 or 2 schools in the entire country has an education around it. And this team hired mostly PhDs. So there are 2,000 PhD engineers in the logic technology development org of Intel. And all these PhDs are hired because they have the background and the ability to pick up on something very, very complex and learn it quickly and apply it, but at the same time with keeping it in mind that you can innovate beyond what you are learning, and that's the expectation. For positions like that, you do need a PhD. They only hire PhDs, literally, from any technical engineering discipline or science disciplines. But if you want a position which does like a lot of design work or regular engineering work, you may not need a PhD. The team admin, you don't necessarily need a PhD to be there and to be successful, frankly. There are a lot of engineers who are really, really good. They don't have a PhD, but they're intellectually very capable. They're very good problem solvers, and they haven't lost 5 years of pay while they were in school, right? So yeah, you can get that experience. So yeah, it's kind of a complex question. Some jobs you need PhDs, many jobs you can do without the PhD.
Thank you so much. Well, speaking of excelling in your industry without having to do graduate studies, we have a question for Ram. What was your mindset early in your career? And did you ever consider graduate studies, or were you really leaning towards immersing yourself in the industry?
Yeah, so my mindset was kind of changing. So when I was in third year, I thought of going for a higher studies, and I also qualified. There is an exam called GATE that's kind of common entrance for entering into master. So I qualified that, and I thought of going for a higher study. But when I entered into fourth year or seventh semester, my mindset got changed, and I thought of getting more experience of real industries. And my plan was I am kind of gonna work for 2-3 years or 4 years probably, and then go for higher studies. And when I entered into industry, I saw that there is so much more to explore here, and I didn't feel a need to go for masters then. So yeah, I can say I was more leaning towards industry during my
Okay.
fourth year. Yeah, yeah, and yeah,
And
I mean,
you're doing well. You're doing well. You're really accomplishing a lot in your career. So that's
I
really
guess so.
encouraging.
Yeah, I'm learning a lot. I mean, I am not missing my higher studies because I have so much to explore here. But that is just in my case, and like little back, Columbia was also explaining. I mean, it's depends on case to case. Sometimes, if you really want to go for higher studies, you can go for that, or sometimes you can explore much more being in the job. And yeah, it's always hard to get back to studies once you get into job. And if like now, if I think of going for uh, masters or higher studies, it's kind of little difficult for me.
I can totally relate to you.
Yeah.
Uh,
You can do it.
Okay, I take your words. I take inspiration from you.
Just make sure
this,
you really want to do it, though.
mm-hmm.
Yeah, that's the inspiration it has to come from within. Yeah. But I'm
This,
worried I should not lose my age, right? So
You
yeah.
won't.
It's not about the age. It's about your skills and your experiences. I totally agree with that. The second question we have for Ram is, this is a little bit personal, but in terms of your career,
Mhm.
what was the best decision that you have made?
Oh, mm, I think there is not one best decision, but I think uh, there are series of decisions, or rather, I would say attitude, that I kept myself open for new areas. So, like for example, when I joined, I was given human simulation work. I was working with human simulation, and there were other opportunities regarding tool and fixture design. So I showed my interest and entered into that team and did fixture and design stuffs. Then moved to assembly simulation, moved to machine design, a lot of things, and new line setup activities. And then yeah, and then the best decision, I would say, that I moved to product design. But this is because of, I guess, the attitude of being open to different fields. And now if I look back, all those works that I did is helping me largely in my product design experience, because I think having an experience of time study or machine design or uh, tool and fixture design, I am uh, a better product design engineer than I would be without having those experiences. So yeah, there's still a lot more to learn, but yeah, that's how the life is.
That's really helpful. Trying out a lot of things not limiting yourself to your field, but again, taking those experiences from fields that you first thought like, oh, this is not related to my career. Maybe this is just a waste of time. It's not. It's actually not. So.
It's not. And I feel whatever you learn at that point of time, it might not seem like it's related to your work, but everything that you learn gonna help you in some way or the other.
Yeah.
And whatever do, just we should do it well.
Yeah, I totally agree. Thank you. Thank you so much, Ram. Now to William, in your opinion, what is the best quality or what is the best skill as an early career engineer? What is the best skill that they should have in order to be successful?
Sure, that's a good one. It's also hard to narrow it down to one skill. You know, we have to have several aptitudes, of course, but I think, and we've said this a lot in this whole discussion, being flexible and being open-minded, it's really going to open doors for you. If you're thinking too rigidly about how your career will end up, or even if you overanalyze your initial trajectory, where you think you'll start, I think you can kind of get paralyzed. So I think being flexible, you know, obviously in pandemic times, it's demanding even more of that. And I think whether it's that or the way the economy changes, things in the world changes, where you can work changes, you really need to be flexible to that. I would refer back to, there have been a couple mentions during our discussions here. And I think Columbia mentioned that a PhD is a way of thinking. I would break that down and say, you know, an engineering degree and studying engineering really, aside from the facts and like the specific things within mechanical engineering, you really are ending up with a way of thinking. It's a whole mindset for problem solving. And if you approach anything, I had to do this with learning how to run a business. It's totally different sets of problems, but as a mechanical engineer, I'm able to break it down. I'm able to create that problem statement and use my tools to you know, find a solution and reach an outcome. And I think that's the case. You know, remain open-minded, see everything as an engineering problem, or at least frame it that way. And there's really nothing you can't do if you approach it that way.
Thank you. I think we also have another question for you. You mentioned earlier when you talked about your company and when you gave out advice for early career engineers that building your network is probably the most important thing you should do. In terms of building your network, what kind of advice can you give in order for us or for everyone who's watching, in order to efficiently and effectively build your network and get you the right opportunities to progress in your career?
Yeah, that's a really good question, and I answer this a lot for students that I mentor and advise at Seattle University. There's some really basic things you can do. If you don't have a LinkedIn profile, I don't represent LinkedIn, but it's where business networking occurs. And one thing you can do is certainly get a profile there, or at least join up and find some industries that you're interested in. So ASME, find ASME's LinkedIn profile and follow them. It means you'll start seeing news from those industries. Even if it's one you don't think you'll work in, it just kind of puts you in the context and lets you see some news and some names and some people who are involved. The other piece I'd mention is become a part of these industry associations like ASME. Depending on what industry you're interested in, you can find those associations that they typically have monthly meetings. They have some form of networking kind of built in. They love having students join. A lot of the professional associations, of course, it's people who've been in their career for a little while, but they love having students, even just who are kind of exploring and trying to get ideas. So just kind of get out there, see what companies are working in the area you're interested in, and then let your curiosity kind of take you. Don't ever hesitate to reach out to people that you see out in industry, and just start asking questions.
Thank you for joining the webinar. I hope you've enjoyed the ASME FutureME career webinar with our 3 amazing panelists, William, Ram, and Columbia. At this point, I would like to invite all of you to participate in our video submission project. This project encourages all ASME members to showcase their early career accomplishments through short videos and provide an opportunity to be featured on our Facebook and other social media pages. Participants may also be invited as a panelist for future ASME events. Through this video submission project, we will be able to feature amazing stories, inspire the current and future generation of engineers, and create strong connections in our community. So if you're interested in participating, please check out the links below and stay connected with us on the ASME FutureME social media pages. The deadline for video submissions is on January 31st, 2021. For more information, please feel free to reach out to us at earlycareerengineers@asme.org. We're excited to see your videos. Enjoy the rest of the ASME eFest.